welcome back. You're going to put this paper to the side, page 295, put it to the side. We're going to cut it up later and put it in our journal. Now we're looking at page 297, where we're going to plot some more points and kind of expand our thinking and challenge our thoughts a little on this one. That's pretty fun, though. Number 26 says, plot a point at 110 and label the point A. Okay. Over 1, up 10. And label it A. The next one. Plot a point at 1, 7. Label the point B. So far, those are in a straight line. Can you see that? Okay, this one's called B. Next one says, plot a point at 8, 10. Label the point C. Over 8. Up 10. Ooh. Now it's on the same line as A. That one is. And the next one, plot a point at 8, 7. And label the point D. Over 8. Up 7. Ooh. I can see what we're doing here. Can you see what we're making? It's shape. All right. Oh, connect the points to form a quadrilateral. That's such a fun word. Say quadrilateral. Quadrilateral. Great. Connect the points to form a quadrilateral. Most children in elementary school call this shape a rectangle. A rectangle is a quadrilateral. Quadrilateral just means 4 sides. That's all it means. So is a square a quadrilateral? Yes. Does a square have 4 sides? Yes. Okay. So we did all of those things. Let's go back through and put little checkpoints. Did we put at 110, did we put an A? Yes. Did we put a B? Yes. C, D, did we connect the points? Yes. That's going to be kind of how you do these assignments, is go through each step and check it off as you go. Sorry, we should have been doing that as we did it. Number 27, this is on your assignment and on the test. So I don't know if we want to like star this or underline it in yellow green so that you're like, oh, I really need to know this stuff, because you do. It says, explain how subtraction can be used to find the lengths of line segments AB and AC. Oh. So they're asking us to compare the line that goes from A to B, this line, compared to the line that goes from A to C. Let's use the other color for that one. A to C. They're saying, how can you use subtraction to find out the lengths of these segments? What? Some people might be going like this. Well, you just count over and then you would subtract how many you went down. And some people are thinking, what does that even mean? Well, take a look. If you look at just the numbers, we have 1 and 1, 10 and 7. So what is the vertical, well, in this case, is it a vertical what is the vertical difference between 10 and 7? We know they're on the same one line, A to B. So you're looking at it like this. Take your blue crayon. You're looking at what is that difference. You probably should know this right now. What is the difference between 10 and 7? 3. So I'm just going to kind of write that with a pencil right here. I know that the vertical difference is 3. And what about the next part? I have a 10 versus a 7. Oh, that's a vertical difference of 3. So I know the vertical difference each time is 3. It means that's how wide the shape is. That's how up and down it went, was 3. Let's prove that. Will you take your finger on B and count up till you touch A? Don't count, don't say the number 1 until you move to the next line. 1, 2, 3. The vertical difference is 3. How do I find the horizontal difference? Horizontal means left and right. Oh. How would I find the horizontal difference? I would have to look at the 1 compared to the 8. So that's pretty interesting. I would have to compare those two numbers. How far apart are they? They're 7 apart, because I know the difference between 8 and 1 is 7. I'm going to pencil that in right there too, just like right here. So just by using the subtraction of these combinations, I know that the vertical difference is 3 and the horizontal difference is 7, right? Let's just check. From A to C, count when you make your first move. 1, 2, 3, 4, 5, 6, 7. So it really did work like that. Super interesting. So what we ended up doing was comparing our x coordinates and our y coordinates to find out what the difference was. Does that make sense to everybody? Okay, so how are we going to say that with words? Explain how subtraction can be used to find the lengths of line segments AB and AC. You're just going to say this. Subtract in this case it was the y coordinates. Subtract the y coordinates to find the vertical difference. And that makes sense because vertical means how tall or how far up something goes. So subtract the y coordinates to find the vertical difference. And then we're going to say the next part. And subtract the x coordinates to find the horizontal difference. I would save this phrase for your homework and remembering, because this is a question on there. Number 28 says, in the coordinate plane above, draw a rectangle that is not a square. Okay. Draw a rectangle that is not a square. Everybody's going to do everyone's going to do this one. You ready? Let's use the actual x. Let's use the x line, okay? Let's put one right on the 4 and right on the 8. And then let's go up 2. So you have to come over to the 4 and go up 2. Okay. I just created one that was 4, 8, up 2, up 2. Connect them. Is this rectangle in the coordinate plane even though it's touching the x-axis? Yes, it's still considered part of it. So, it says, what ordered pairs represent the vertices of the rectangle? Oh no, we need to label them. You can't just put points on without understanding the label. So, let's just call it E, F, G, H. And we started on the top left and went E, F, G, H. Okay, so what ordered pairs represent the vertices of the rectangle? Well, here's E. You put a little colon after it, and then you put parentheses with a comma. That's how you need to do this math. You have to have parentheses. E was over 4, up 2. Over 4, up 2. Let's go down to G. Let's do G. G was over 4, up 0. So it's just 4, 0. Let's do F. F was over 8, up 2. And H. Over 8, up 0. Number 30. Write a subtraction equation to represent the length of the rectangle and write a subtraction equation to represent its width. Don't panic. Length, how long something is the horizontal. Its width is how tall something is, or it's vertical. So now look at the stuff we wrote on 27 and see if you can figure out what the subtraction would be. Well, to find the horizontal difference, you subtract the x coordinates. Okay. The x coordinates were 4s, and what was the other x coordinates? 8s. Oh. So the length would be 8 minus 4. Because it says it wants a subtraction. And it wants an equation. So I'm just going to write this as, when it's horizontal, x. 8 minus 4 gave me how long it was. And now I go for, what's the next thing they asked? Width. Okay, to find the width, which is the vertical difference, subtract the y coordinates to find the vertical difference. Oh. So I find the y coordinates. Where are they? So we're not talking about the x's anymore. Whoop, done with the x's. What are the two numbers you see that come up in the y coordinates? I see a 2 and a 0, a 2 and a 0. So it's a 2 minus 0. The width equation is 2 minus 0 equals, what letter would you use for this one? Y. Very good. I'm really proud of you for that. Y. Why do you use Y? Because that's how tall or how wide the shape was going up. Okay. Very good. We did it. Good job. Turn the page. I love Puzzled Penguin. We have not talked about him a lot this year, but he is so adorable. He makes all these little mistakes, and he's just like, he just needs some help. So let's help him out. Dear math students, I was asked to name the location of a fourth point that would form a square when the points are connected by line segments. I think the point 7, 4 would form a square. Do you think that is correct? Let's just see. Will you take your yellow green and connect what he has so far? Okay, the backwards L. To have a square, it has to be equal on all sides. So let's take our pencil and put the point where he thinks it goes. Over 7, up 4. That is where he thinks it goes. If I connect these points, it will make like an airplane triangle thing. Actually, it still would make a quadrilateral, but it's a weird shape. Does that make a square if he puts it at 7, 4? No. What was his mistake? Do you know where the point should have been?
Oh.
Where should the point have been if he wanted a true square? It would have to be on this line, and it'd have to be up as high as this one. The point needed to be right here. I'm going to put some arrows over here. The point needed to be here. You need to do the same thing. So what was that point supposed to be? Over 4, up 7. And he said it was 7, 4. What is his mistake? What do you think his mistake is? Number 10?
He put the 7 first instead of the 4.
Yeah.
So he switched the X and Y up.
Very good. He switched the X and the Y coordinates up. He thought that you went up and then went over. Does that make sense? He did not think that correctly. You need to go over then up. So if I were to write a response to Puzzled Penguin, I would have to explain that thinking to him. So let's go ahead and write a response to him. Ready? This is a letter. He wrote, Dear Math Students, so you should say, Dear Puzzled Penguin. That's his name. And if you're telling someone that they're wrong, does that feel good when people just start saying, you're wrong, you got it wrong? No. What is a good way to start a letter like this where you're trying to correct a mistake? A good way might be something friendly like, I can see that you are working on learning the coordinate plane, right? Something that's like, yeah, you're working hard on that. You just don't have all the steps yet. What would be a good way to start this, do you think, Dawson? Oh, number one. It's all right. Number one.
Sorry.
Your mom will give me permission.
I think a good way to start this would be, Dear Puzzle Penguin, I can see that you're working hard on learning the coordinate plane.
Okay, stop right there. You're going to keep helping me in a minute. I can see that you're working hard on learning the coordinate plane. Okay, what next?
And then say what his mistake was. So then say, but you switched it around.
Okay, that's a great way to say that. I can see that you're working hard on learning the coordinate plane. I would say, however, you made a mistake that actually makes a big difference. It's a little tiny mistake, right? But it makes a big difference. That actually makes a big difference. Okay, so that's a statement. Now we're going to tell him what the mistake was. However, you made a mistake that actually makes a big difference. The x coordinate must go first. Comma, then the y. The location should be, and then we're going to tell them the right answer. Put it in parentheses. Over 4 up 7. How do you end a letter like this? You just end it like that, or do you say like, keep working hard, or better luck next time? I'm going to say better luck next time. Oh, I'm out of a line? That's okay, you can write it down here. Better luck next time. And then I should sign it sincerely or your friend. I'm not going to make you sign it, but that is a good way to write this kind of a letter. On the assignment or test, you may be asked to correct a situation like this. So you need to be careful when you're figuring that out. It says, Dear Puzzle Penguin, I can see that you're working hard on learning the coordinate plane. However, you made a mistake that actually makes a big difference. The x coordinate must go first, then the y. The location should be 4, 7. Better luck next time. Yay, I feel really good about helping him with that. Here's what we're going to be cutting out and using in our journal. You ready for this? You are going to turn in your response to Puzzle Penguin to me. So you will want to make sure that your name and number are on the top of page 297. So you'll turn that into the basket when we're done. Not right now. But right now, we're going to take a look back at page 295 and get out scissors and glue stick. Because we're cutting out the actual coordinate plane. We're cutting out what an ordered pair really is. So we're cutting out number 1. We're cutting out the coordinate plane, but round up, like bubble cut it out. And we're cutting out all of 3 through 10 so that we can see how we use that plane to find these points. Okay, so here we go. We're cutting out number 1. Be careful not to cut things off. We're cutting out the coordinate plane. And we are cutting out the directions to numbers 3 through 10 with number 3 through 10 with it. So it's like a little thin strip at the bottom. We should have 3 pieces that we're gluing in. Don't forget the directions on 3 through 10. There are the 3 things you need. The rest of this you can recycle later. But here's how it gets going into our journal. Once you have all three of those things, they need to fit on the same side of your journal that you've already been working on. I don't want a new page for this. So you're going to have to be creative about how you put this in. Maybe you'll have to trim off a few more things like I am having to get it to fit. Remember, you can't cover up a hole in your journal. So yeah, trimming the left and rights is going to be really important. I think I can get this to work. I'll have to trim my coordinate plane a little more. Do not cut off the X and Y on your coordinate plane. That's important to keep on there. Okay. Mine looks a little bit crazy, but it all got on there. Maybe I could do it a little differently. No, I like it like that. I'm okay with that. Okay. Get it glued in or taped in, and then when you're finished, you can work on the homework and remembering to 7.5. Thanks for hanging in there.